Assalamualaikum and hello everyone. Welcome to the video for 2.4 Born-Haber cycle. In this video, we will construct the Born-Haber cycle for simple ionic solid and then calculate enthalpy changes using Born-Haber cycle. So we have looked at the first example, and then right now let's look for the third examples. Okay, so here question number 3, construct the Born-Haber cycle and determine the lattice energy. Okay, so what is the compound that we are interested in? It is actually my CaF2 solid. Okay, so why does it CaF2? Because it is actually based on Ca is actually 2 plus. Calcium is 2 plus, fluorine is minus. So what will be the product? The product will be CaF2. Okay, so this is the product itself. Okay, so next, what we're going to do is actually we're going to draw the Born-Haber cycle using all the enthalpies. Okay, remember what we're going to do is actually write down the equation for each. Okay, FAIEL. Okay, from here, it only write down the enthalpy. So we have to determine which one is which. Okay, so for this case, the first one, calcium solid will become calcium gas 1 mole. Here is 1 mole of gaseous atom. So here is the atomization. So atomization of calcium. Okay, next, okay, please add it in your notes. It's actually fluorine gas, not fluorine solid. Okay, so here from 1 mole of atom, gaseous atom, from the stable element, again atomization, but this time is for fluorine. Okay, next one, calcium gas will become calcium plus gas. Here it does not show the electron, but then we know because it is positive, so here plus electron here lah. Donate 1 electron. So here is the ionization energy. Okay, next one, from the Ca plus gas become Ca2 plus gas. Again, we know that because we will donate 1 electron, so the positive one become positive 2. So here is another IE. Okay, but then which one is which? For this one, we have to specify. So this is actually the first ionization energy when we remove 1 mole from 1 mole of gaseous atom. Okay, so when we donate another one, okay, from the Ca plus gas, so it will become the second ionization energy. Okay, done for the ionization energy, atomization. Okay, next, fluorine gas become fluorine minus gas. So again, when we have minus, negatively charged ion, so it means that it accepts electron, which is electron affinity. Okay, last but not least is the 1 mole of CaF2 from the stable element, calcium solid and fluorine gas. So here is the formation, enthalpy of formation. Okay. So from here, we do not know the lattice energy yet, so we have to draw the Born-Haber cycle. Okay, so for the Born-Haber cycle, we will start with the formation. Okay, once we have a draw for the formation, next is actually for atomization. So we can do for calcium as well as the fluorine. But then again, when we look at it, okay, so here is my F2, here is my fluorine. So what happened here? This is not the atomization, because remember, atomization is half F2 becoming F. Okay, so here is true, it's becoming F, but here is F2. So the equation is not balanced, but how should we write it down? So should we write down half here? If we write down half here, so what happened is that here is F. But then we know that formation here, we do get F2. The formula itself is CaF2. So this one is correct. So what should we do with this? So from this one, okay, I'm just going to write down the equation for you. So here is the atomization. Here, half F2 becoming F. Okay, but for this case, we cannot write down half here because here is already 2. So how should we do it? Here we have to write down 2. Okay, then as you can see, this equation is becoming F2 become 2F gas. Okay, but then what about the value? The value won't be the same lah as atomization. So what happened? So as you can see, the difference is this one we have to multiply this equation by 2. then you get the purple equation. So for the value itself, so you have to multiply this by 2. So here pun multiply by 2. Okay. Tapi kenapa ni kat sini lain? Rasanya sebelum ni belajar macam lain. Okay. Because from the example 1 itself, we can see the ratio for the product is 1-to-1 ratio. And then from the stable element, we have to write down half to become our atom. Okay. This equation is identical to the atomization. Memang sebiji. Memang tak salah apa-apa. Memang betul sama. So kita ambil sahajalah. Tapi dalam case example 3 and example 4 ni, nanti kamu akan buat sendiri. This is not 1-to-1 ratio. Ini kan ada 1 calcium, 2 fluorine. So kat sini memang betul lah. There's no need for you to write down half. Kan? Tapi bila tak ada half dekat sini, it is not the same as atomization. So what should we do? So kat sini kita kenalah. From here, to balance it out, times 2. Here pun times 2. Okay, so first and foremost, make sure memang your formation is the correct equation. Okay? So make sure, check balik dekat sini. Ini betul. So maknanya what should we do? We have to multiply the value lah. Okay, so next one, atomization done, formation done. Okay, next one is ionization energy. Okay, for the ionization energy, when we look here, we have 2, 1, 2. Okay, so what should we do? Okay, it's because started from calcium first. So we have to show by one. So from calcium gas to become Ca plus gas. So we can't do terus calcium gas jadi Ca2 plus gas. Cannot. We have to write down one by one. Here Ca plus. Then we have another Ca2 plus gas. We have to do step by step. Because each of it, we have different values. So that is for ionization energy. Again, we have to do one by one. Cannot straight to Ca2 plus gas. Okay, next is electron affinity. So we only have one electron affinity. Okay, so if we just write it down again, so we do get this value. But then remember, here is actually the ionization, the electron affinity is from fluorine gas become fluorine minus gas. But since here we have 2 fluorine, so here we have to write down 2. Here pun multiply by 2. Okay, remember, macam ni lah. And then when we check it again, memang semua ni pun memang balance because remember here fluorine we got 2, here 2, here pun 2. Last but not least is the lattice energy. Okay, so lattice energy is actually when our gaseous ion combine to form 1 mole of ionic solid. Okay, tapi dekat sini it means that the equation that we are interested in maknanya Ca plus 2F minus, then we get CaF2. Macam ni kita nak buat ni. Takkan nak buat macam ni, lepas tu arrow dia macam ni kan? Takkan nak buat macam tu. Because tadi, from the example 1, memang dia sama saja. So kita buatlah, boleh buat plus tengah-tengah, terus yang ini. So takkan yang ini nak buat plus macam ni, macam ni. Takkan nak buat macam tu. Okay, so what should we do next is actually, okay, kalau dah buat, okay, padam balik arrow ni. Okay, rearrange balik equation ni. So yang ini, the 2F minus here, I'm just going to write down this sama level dengan Ca2 plus. And then we're going to draw the arrow again. So, okay, dah. Okay, and then lattice energy is when the gaseous ion reacted and form 1 mole of ionic solid. So, here is my lattice energy is equal to X. Okay. Okay, so from here we can do the calculation. Okay, yang ini, again, if you're a bit unsure, tengok balik kenapa dekat sini lah. Believe ini kamu confuse sikit. It is because from here, make sure the formation is balanced. Then from the formation, if the equation is a bit different, from the equation is a bit different from our enthalpy, selalunya beza dia darab 2 je pun. Darab 3 tak ada, bahagi, divide by 2 pun tak ada. Memang selalunya darab 2 sahaja. So, itu je lah. Just check it. Okay? So, from here, we can calculate our lattice energy. Okay, but then from here, remember when you calculate it, formation is equal to all of this. Since the atomization for our fluorine multiply by 2, so here I write down 159 times 2. The same goes for the electron affinity times 2. But the lattice energy is the same kan? Okay, so that is actually for example number 3. Okay, so for example number 4, pun the same one. Okay, here I'm going to help you. Kita tengok MgCl2. Okay, why MgCl2? It is because Mg2 plus Cl minus. We get MgCl2. So how about the formation? Okay, remember MgCl2 solid. It formed from the magnesium and chlorine. Magnesium is group 2, memang solid lah. Okay, chlorine, the stable element group 17 is chlorine 2 gas. Okay, but then kita check, is it balanced? Balanced. Okay, so this is the formation. Okay, yang lain-lain tu sama sahaja, is the same as question number 3 ni. Dia jadi lain sikit daripada example number 1 is because our atomization tu. Hence, yang sini pun ada berubah sikit lah. Okay, so that is for question number 3. Okay, next question. Okay, example number 5. Okay, yang example number 5 ni copper 2 oxide kan. Okay, yang kita pun, okay, what is the formula for the product? So remember, so dia kata copper here, Cu tapi dia bagi 2, charge dia 2, Cu2 plus dengan O2 minus. So our product will be CuO. Dia bukan Cu2O2. Sebab dia dah sekali cancel out kan, so dia jadi CuO. This will be the product for number 5. Okay, number 6 is this is the example where I have mentioned it to you. This is the example where this is the energy level method, and they ask you to determine what is the enthalpy involved. Okay, so let's look here. Okay, kat sini kita tengok we have our potassium and bromine. Okay, from here bromine sebenarnya bromine pun ada liquid jugalah, tapi most of the time kita akan guna gas. Selalunya kalau for the lattice energy, memang semua ni akan jadi gas except for our product here dengan kita punya metal di sini. Yang lain semua gas. But certain time dia bagi bromine tu liquid. So kita terima sahaja. Okay, so for this example, they ask you name the enthalpy changes shown below in Born-Haber cycle for the formation of potassium bromide. Okay, so right now we have to determine based on here which one is FAREL. Okay, so kita tengok dulu. I'm going to highlight the differences first. Okay, so from here, contohnya from H1. Okay, H1 ni the arrow kan. They are forming my ionic solid. Sebenarnya ni lah, ni formation. Okay, tapi the second one here, the changes is actually from my solid become my gas. Okay, so maknanya sini, here must be my atomization. Tapi atomization of what? My potassium. Okay, next step kita tengok apa lagi. Okay, the changes here from K gas. Okay, the difference is K plus. So this is actually the ionization energy of K. Kita tengok one by one. Apa yang the difference dia? Ini is from the start sama sahaja bromine ni. So it does not involve any bromine yet. Okay, but then the H3, the differences is from half Br to liquid, it become Br gas. Br gas. Okay, so here is the atomization. Atomization of what? Of bromine. Okay, last one from this equation downward here. So what is the difference? Is it K plus? Does not. So here from Br gas to Br minus gas. So here is the difference. Okay, so that is the electron affinity. And last one must be the lattice energy. So here is the lattice energy. Okay, for here is just you have to determine which one is which. It seems macam a lot, tapi sebenarnya determine what is the differences. So here will be the answer. Okay, so make sure write down it is enthalpy. Enthalpy of what? For the case of formation and atomization. Of what? Is it K? Is it Br? So we have to be specific lah. Of ni pun kena write down juga. Okay. So that is for example number 6. So that's for example number 6. Next example number 7. So here it mentioned the figure below shows the Born-Haber cycle for CaCl2. Okay, so first it mentioned write down the equation for P and Q. So where's my P and Q? Here is my P, here is my Q. Okay, and then here it mentioned it is the first ionization energy of calcium. So for the ionization of calcium, the ionization energy, it means it donate electron kan. So it will become Ca+. Okay, but then don't forget the Cl2 is still there. We have to write down, even though it does not change anything, we have to write down this one as well as the Cl2 gas. Okay, next for Q. So here it mentioned about bond energy of Cl-Cl bond. So what is actually the bond energy of Cl-Cl bond? Okay, for example, if I have for example, here is the atomization. Atomization when one mole of atom is formed from the stable element kan. So this is atomization. So what is the bond energy? It's actually yang inilah. The bond energy is between these two I. Kan? What is the bond energy here? So this is we define it as bond energy. So bila kita tengok example 3 tadi, this is example of our bond energy. Bond energy. It's not enthalpy of atomization is different. Bond energy is different. Okay. So here for the case of bond energy, so it means that my Cl2 will become 2Cl. Okay, but then again, for this part, we have to write down, even though the process is only involving the chlorine, we have to include the calcium as well. Okay, so that's for question A. So question B, name the enthalpy change for H1, H3, H7. So H1 here, H3 here, H7 here. Okay, so let's look. What is the difference in the enthalpy itself? Okay, so between this equation and this equation, the difference is actually for my calcium. So for my calcium here, solid dia jadi calcium gas. So that is the difference. Okay, next is actually H3. So H3, kita tengok. So this is my H3 kan? This is my H3. The start dia. And this is the equation dia. So the difference here is actually from my Ca gas jadi Ca2 plus gas. Okay, next is H7. So H7, yang ini yang paling awal sekali, yang paling penting kita belajar kita punya Born-Haber. So here is between yang Ca plus Cl2 to form CaCl2. Okay, so what is the answer? So yang ini. Okay, so this is the answer. So quite straightforward. Cuma yang ni, remember it's second ionization energy because we remove one more electron. First ionization energy become Ca plus kan. The second one akan jadi Ca2 plus. Okay, last but not least, C. Calculate the lattice energy of CaCl2. So which one is the lattice energy? Lattice energy is H6. This is the unknown. Okay, so how do we get the value? How to find out the L? Okay, again, we're still going to use F equal to A plus I plus E plus L. Okay, in this case, our F is H7. So we have to add up all the H together to get the F. Hence, next we will get the value of H6 itself. You should get this value. So again, for this case, the bond energy ni, memang this is the bond energy given kan. Dia bukannya bagi tahu H4 ni atomization. It does not mention it to you as that. It is the bond energy. So yang ini, we can take it straight away. Masukkan saja. So plus 2 for 2. No need to times. Question 8, I believe you could try yourself. For question 9 and 10, here I'm just going to write down the formula for it. So for calcium chloride, Ca2 plus Cl minus will form CaCl2. Here magnesium oxide, tapi dah bagi sini MgO kan? Senang lah because it is Mg2 plus with O2 minus. So dia jadilah MgO. So in this case, buat dia O2 minus, you will get second electron affinity. Okay. For the case of question 9 dengan 10, dia ada tricky dia sebab does not ask about the lattice energy. Dia suruh dia minta yang lain. Here, they ask you determine the electron affinity for question 9. Question 10, they ask you to determine the second ionization energy for magnesium. Okay, so that's it for this video.